Okay, we're going to look at concave mirrors. We're going to look at one specific situation. We'll make one for each, where the image is farther than the center of the mirror. So, in our concave mirror here, we've put it on a Cartesian place so we can count. And a concave mirror is technically like a spherical mirror with the image is within, but it can be really hard to understand this as a circle. We'll get rid of our actual circle here. So now it looks like a concave mirror. We have three formulas that come in very handy for this. The first one is that the focal point is half the distance to the mirror as the center is. Okay, so the center, that was the center of our circle we had. Remember, the circle went around. We have another one that 1 over the focal point is equal to 1 over the distance of the object plus 1 over the distance of the image. And the last one is the magnification is equal to height of the image divided by the height of the object equal to negative distance of the image or distance of the object. So if you need to memorize those, you can pause the video right here and take a look at what each of them stand for, but we're just going to go on the assumption that you know now. So here's our mirror. So we're going to draw our object. And here we go. We'll say that the object is at 8. Okay, so in other words, it is 8 units, 8 centimeters, whatever you want the measurement to be, from the concave mirror. And as you can see on the plane, that it is 2 units again, so 2 units high and is 8 units long. So that means the height of the object, because this is the object in the mirror, is 2 units. And the distance of the object, okay, is 8 units. We also know the center is 6, and it means the focal point, which would be half of it, right? If that was 6, 6 divided by 2 gives the focal point, is 3. We'll put U there for units. So we have quite a bit of information from this. One of the rules we're going to discover is that with a concave mirror where the image is farther than the center, we're going to end up with an image. Okay, so the mirrored image is going to be somewhere between the focal point and the center, and it'll be a little bit smaller than our original object. Okay, so the way to draw this with arrows is we'd have an arrow going right to the mirror, and then it would go through the focal point downwards. Okay, so there's our first one. The second one, we'll do it in red just so you can see the difference, would go through the focal point to the mirror, and then wherever that point is, it would come parallel from there. So this new spot, okay, I guess we'll do it in green, where these two lines cross, that would be the image, okay? And as you can see, it's between the focal point and the center. That makes sense. And it looks like it's less. It looks like it's less the image, whatever it is. So we can actually calculate this information. So formula 1 we already know. The center is 6, the focal point is 3. There's nothing to work with. The second one, we have our focal point. So formula 1. 1 over the focal point we said was 3 is equal to 1 over the distance of the object. The distance of the object was 8 plus 1 over the distance of the image. The distance of the image. Okay. So in order to find the distance of the image, we have to isolate for the distance of the image. So we have two fractions. So we'll move one fraction to the other side. 1 over 3 subtract 1 over 8 is equal to 1 over the distance of the image. Okay. Now we're going to make the denominators the same because we're subtracting fractions. So very quickly, instead of trying to find a common multiple, I know I can multiply this fraction by the denominator of the other fraction, and then vice versa, this fraction by the denominator of the other fraction. So that being said, we have 8 over 24, subtract 3 over 24 is equal to 1 over the distance of the image. We end up with 5 over 24 is equal to 1 over the distance of the image. You can cross multiply if you like now. So you get distance of the image times 5 is equal to 24. So the distance of the image is equal to 24 over 5, which looks like it's just a little under 5. And we'll bring up our calculator. If we want it in decimals, 24 divided by 5, that's 4.8. Okay. So the distance of the image is equal to 4.8. And if we take a look, that's not bad from where our Cartesian plane is drawn. It looks like that could be at the value of 4.8 for the distance of the image, the mirror image. Okay, that's good. Next, we want to find the magnification and also the height of the image. Okay, so we'll use our third formula here. So we scroll down. Third formula states that the magnification is equal to the height of the image over the height of the object, which is equal to negative the distance of the image over the distance of the object. And we have a bunch of this information. We just found the distance of the image, okay, and it's 4.8, so we have negative 4.8 divided by the distance of the object. We had that up here, that was 8. Okay. The height of the image is unknown, and the height of the object, we said, was a value of 2. This is, again, equal to the magnification. So we have 3 ratios equal to each other. We could find the magnification by literally just dividing these two, and we'll have the magnification. We could also just focus on these 2 equivalent ratios to find the height of the image. So let's set the magnification to start. The magnification is equal to, we have negative 4.8 divided by value of 8. Okay, and negative 0.6. So our magnification is negative 0.6. Okay, and now let's focus on just the height of the image. So the height of the image over 2 is equal to negative 4.8 over 8. We can isolate height of the image by just bringing the 2 over and multiplying this side by it. The height of the image is then equal to negative 4.8 times 2 divided by 8. And there's a couple ways you can go about doing this. I can actually just cancel these out and make that a 4. Think of it like 2 divided by 8 gives us a 4. However you want to go about that is fine. Height of the image is equal to negative 4.8 over 4, which means the height of our image is equal to, we'll use our calculator again, negative 4.8 divided by 4, negative 1.2. And again, that's in units, so let's go up and take a look. And negative 1.2 is a pretty good estimate for what that would be, negative 1.2. So that looks like it worked out quite well there. Another way to have proven that is we know that the magnification, went down a little too much, is negative 0.6. Well, the original height of the object was 2. And if we multiply that by negative 0.6, we end up with the height of the image, okay, because the magnification would find us the new image, of negative 1.2, which is exactly what we found on here. So I guess you could even write another formula that the height of the object times the magnification is equal to the height of the image, which is pretty much in this ratio. We just don't write it out that way. Okay, so again, all of those things came true when we looked at our Cartesian plane here.